Okay, I'm just going to go over the answer for the practice number 1. It's pretty self-explanatory. I've got the writing here. Just go through it just to if you need a little bit of support with this. The first thing you were to do is pose a comparative question. So the variables that we're dealing with here is time in seconds, by the way, that the students can stand on their left leg with their eyes shut. And we've broken it up into females and males. So remember the question. The question has to have a variable, which is the standing on one foot with eyes shut. The groups that we're comparing, in this case it's males and females. The population reference, which is boys and girls or males and females in New Zealand, and that's the only criteria we know about at this point. And the statistic, which is the difference in the sample medians of time, basically time that they can spend on one foot. So your question has to have all those elements. So here's a typical question. Doesn't have to be the way it's written exactly, but something like this. What is the difference? So there's your comparison in the median time in seconds. Probably a good thing to put the units. That male students, one group from New Zealand population, can stand on their left leg with their eyes shut in comparison to the median time female students in New Zealand can stand on one foot with eyes closed, right? So that kind of gets all the variables and all the things and criteria for a comparative question. Then we get into the description of the distributions of the graphs, the dot plot, box plot thing. And I took this from some students, so most of this is from the students, with maybe a little bit of a fix-up, but some have done a really good job. I can tell the people that have done this last year because they've got a real good handle on it. But anyway, from both the male and female distributions, so that's the graphs that we're talking about, we can see that they both have a right skew. And they do. They both have a right skew. Some of you said left skew. That's not a left skew. That's a right skew. They've got a tail to the right, right? That's a right skew. Furthermore, we can see that the female distribution, it tends to be more normal. So even though it's sort of here, with this data right here, it's quite symmetrical, quite normal. It's got sort of this whole bell-shaped kind of thing going on, at least between 0 and 50. So that's a nice way of saying. Tends to be more normal. That's what we mean. The times are more centered around the median. This is really good. The male distribution is more irregular, absolutely, and is not centered around the median. So that's what this is showing. Yep, this is good. And then they also added here, furthermore, the female distribution is within that of the males. And we're going to talk about that because you guys had really struggled with the shift. The fact of the matter is, if you look at these boxes, one is not shifted past the other. The fact of the matter is that this female box is actually kind of inside the male box, middle 50%, if you will. And so that's not a shift. The fact of the matter is the male box is just wider. It's just longer than the female box. And that has to do with the interquartile range and spread and so on, which we're not going to really address here. But actually, there's no shift. So the male's middle 50% is wider than the female's box as it ends in 64 seconds. However, there's no real shift between the boxes as the female middle 50% is contained entirely within the male's middle 50%. So in this particular case, and this is the reason that I kind of did this, is that I wanted a little bit of discussion about this and a little bit of thinking about this. One box is really not shifted. You know, a shift, if we look at shift, a shift is like this. This is a shift, right? One box is shifted further to the right than the other. But they don't necessarily have to be shifted further to the right or to the left. They could be right underneath each other, which is kind of more the situation here. And so no shift, really, technically. Centers. So if we talk about the centers, this is the averages. In this case, we only have the medians to look at, not means. But if you had both, you would talk about both. So I noticed that the median time for male students, 28 seconds to stand on their left leg. See, context is good with their eyes closed, is the same as a median time, 28 seconds, for female students. This means that in the sample, male and female students tend to be able, on average, to stand on one foot for about the same amount of time. Yep, that's what it means. And the other thing is that this is kind of, you know, you can, if I was to put sort of a hypothesis here, that I would expect there to be no difference between genders in standing on one foot, why would boys or girls be better than the other? Like, I would expect there to be no difference, and that's what I'm seeing. So I would expect this to be true, as I doubt gender would have an impact on balance. So just a little burp about that. And then we've talked about what it means in the sample. This may suggest that back in the population there is no difference between males and females. It may suggest. We're not sure, but that's from our sample seems to be what is kind of telling us. So that's how you would write about that.